Hi, I'm Paige Peters with Notchy TV, and today we're going to learn how to inspect notches, bored holes, and cuts in solid lumber. We will learn how to determine whether alterations in floor joists, stud walls, and roof rafters are structural defects or permitted by the current standards. We will measure, evaluate, and identify numerous alterations that are structural defects. We will learn about simple spans, actual joist depths, knots, thirds, cantilevers, tension, and compression. This is a beam. Any horizontal framing member is considered a beam. The term beam is synonymous with other terms such as joist, sawn lumber member, simple span member, post and beam, cantilevered member, and horizontal framing member. This beam is an example of a simple span. A simple span is a horizontal framing member supported at each end. When a load is applied, the member bends in the middle and rotates at the ends. This is a cantilever. A cantilever member is only supported on one end. When a load is applied, the member moves in a different way than the simple span. The difference between simple span and cantilever is the resulting stresses put on the member, known as tension and compression. Tension and compression result when beams bend. Tension is the stretching or pulling of wood fibers. Compression is the pushing together of the wood fibers. On a simple span, the top is in compression and the bottom is in tension. On a cantilever, the stresses are reversed. The top is in tension and the bottom is actually in compression. The location of the notch directly relates to the area of tension or compression on a cantilever or simple span. Now it's time for a pop quiz. Remember, you can click pause at any time during the video. So the question is, what is the term that describes the pushing together of wood fibers on a beam? A, simple span, B, cantilever, C, tension, D, compression, or E, beam? And the answer is D, compression. And another question. So the compression at a cantilever is located where? A, the middle, B, the bottom, C, the top, or D, the load-bearing point? The answer is B. The compression of a cantilever is located at the bottom. Now let's do some identifications. This is a notch, this is a bored hole, this is a natural knot, and right here is a crack. This here is a span. These are thirds. This is a bearing component. This is an actual joist depth, 11 1/4, 9 1/4, 7 1/4. This is a cantilever. This is tension and compression. So there are a couple steps to the inspection process. Step 1. You need to look for notches and cuts in the joist. Notches and cuts are okay as long as they don't occur in the middle third of the span. Step 2. Check the end notches. The end notches should not exceed 1/4 of the depth of the joist. This is a 2x10. The depth of the notch cannot be greater than depth divided by 4, which in this case is 2 5/16. Let's measure this notch. This notch is 1.5 inches, so it's okay. This is a ledger board. A ledger board is a form of an end notch. Let's measure it. It's 2 inches, so that's okay. A ledger board has to be a minimum of 2 inches by 2 inches. This right here is too short, so it's a structural defect. This is a 2x8. Let's measure the notch depth. Remember that the notch depth cannot be greater than D divided by 4. This one is 1 8/16, and the maximum would be 1 13/16, so this one's okay. Let's check the outer thirds. Notches are permitted in the outer thirds, but they cannot exceed a depth of greater than D divided by 6. And in the middle third, no notches are allowed. This one has a notch in the middle third, so it's considered a structural defect. This is a 2x8. The notch depth should not exceed D divided by 6. So for this board, it'd be 1 3/16. We have a notch here, and the notch measures out at 1.5 inches. So it's too large, and that's considered a structural defect. Over here we have another notch, This notch is only 1/2 of an inch, so structurally it's okay. And right here we have a cut. A cut should be treated like a little notch and measured in the same way. This one's only about a 1/2 inch, so this one is also okay. Two notches located directly above each other are permitted in the outer third, as long as the total depth of both notches do not exceed d divided by 6. Check the ceiling boards. If the top notch in the ceiling board exceeds 1/6 of the depth of the entire joist, then make sure the notch is no further than the joist depth from the face of the support, and the notch does not exceed 1/3 of the joist depth. So let's measure this top notch. This top notch exceeds d divided by 6. Make sure the notch is no further than the joist depth from the face of the support, and the notch does not exceed 1/3 of the joist depth. Let's measure the length of the notches. A notch cannot be greater than 1/3 of the depth of the joist, and this is a 2x10, so it can't be greater than 3 1/16. This notch is 3.5 inches, so it's considered a structural defect because it exceeds the maximum. This notch right here is only about 1 inch big, so it's okay. And this one down here is 2.5 inches, so it's also okay. Cuts are like little notches, and they need to be measured like notches. Because the width is so small, you don't really have to worry about it, but the depth should be measured just like a notch. So in the outer third, the depth cannot exceed d divided by 6. And this one, as you can see, is fine. So now we're going to learn how to inspect overcuts. Overcuts are the little cuts that occur after the notch ends there. And you have to measure them like a notch. You don't measure it from the base of the notch right here. You're actually going to measure it from the overcut. And this notch is already too great. And now that we have this, it's much too large. It's definitely a structural defect. And we'll span over here and look at some more of these overcuts. And right here we have another one. Again, the notch is already too large, but then you have to consider that we're measuring it from the overcut now, which makes it an even larger structural defect. We have an end notch here that's only about 1 inch, but then if you look at the overcut, the notch becomes about 1.5 inches to 2 inches, which makes this now a structural defect. Now we're going to inspect notches and beams. Any beam greater than 4 inches in nominal thickness cannot be notched on the side of tension. So on a simple span, that's at the bottom of the board. But remember, on a cantilever, the tension occurs at the top side of the board. So now we're going to inspect board holes. Board holes can occur in the middle third, as well as the entire span of the board. They just cannot occur within 2 inches of the top or the bottom of the board. This hole right here, this is okay because there's 2 inches at least on each side. This one's okay as well. And then if we look over here at this one, it looks like it might be okay, but it actually occurs within that 2 inches, so it's considered a structural defect. Now let's measure the board hole width. The maximum the board hole width can be is d divided by 3. So on this board, that's 3 inches and 1/16. You look at this one right here, you can see this one's okay. This one, we'll measure it. It's right at 3 inches, so it's okay. The natural notch is obviously okay, as well as this other hole right here. Now let's measure the distance between notches and board holes. There needs to be at least 2 inches between board holes, notches, or the top and bottom of the board. This one right here, it's about 3 inches, so that's okay. Between this board hole and this natural knot, it's about 3 inches as well, so that one's okay. And this here is still a structural defect because it's less than 2 inches from the top of the board. So let's do a brief summary of what we've learned. So far we've learned that you cannot have notches in the middle third, and that end notches cannot exceed d divided by 4, and notches in the outer third cannot exceed d divided by 6. And the notch length cannot exceed d divided by 3. And if there's an overcut, that's going to increase the notch's length. And for beams 4 inches or greater in width, there's no notches allowed on the tension side except for at the ends. And bored holes can occur throughout the entire span of the board. They can just not occur within the top 2 inches or the bottom 2 inches of the board, within 2 inches of a notch, and their maximum width cannot exceed d divided by 3. So now we're going to look at rafter boards. It's very similar to floor joists because notches cannot occur in the middle third, end notches cannot exceed d divided by 4, and any notches in the 2 outer thirds cannot exceed d divided by 6. If there's a notch on the cantilevered section, there has to be at least 4 inches remaining of the rest of the board, and the length of the cantilevered section cannot exceed 2 feet. So I have another quiz for you. Remember that you can press pause at any time during the quiz. So you're at a home inspection and you see a rafter board, a 2x10 rafter board, and there's an end notch. What is the actual depth of the rafter board? What is the maximum depth of this end notch? And is it a structural defect? And the answer is the actual depth is 9 1/4. The maximum is 2 5/16, and this far exceeds that. So yes, it's a structural defect. In a rafter board, bored holes cannot occur within 2 inches of the top or the bottom, and their maximum width is d divided by 3. So I have another quiz for you. Remember, you can press pause at any time. So you're at an inspection and you find a bored hole in the middle third and it's 3 inches from the top. Is the location a defect? Is the size a defect? And the answer to both is no. When the notch exceeds more than 50% of the width, like this one, it needs to be reinforced with a galvanized tie, like this right here. The tie needs to be fastened to the plate, like this, with 16 penny nails. The tie is not required if the whole side of this wall is covered with structural sheeting. Now let's check notches in load-bearing studs. A notch cannot exceed more than 1/4 of the total width. This notch is 7/8 of an inch, so it's okay. Now let's check notches in non-load-bearing studs. Notches in non-load-bearing studs cannot exceed 40% of the width, so this one's okay. When you find a bored hole in a stud, you have to make sure that it does not exceed 40% of the total width of the stud. In a load-bearing stud, if the bored hole exceeds 40% but is less than 60%, the stud needs to be doubled. If there is a double bored stud, there cannot be more than 2 of these in succession. This bored hole is greater than 40% but less than 60% of the width. It should be doubled, but it's not, so it's considered a structural defect. Bored hole should be at least 5/8 of an inch from the edge of the stud. When there is non-metallic sheathed cable going through the bored hole, it needs to be at least 1 1/4 inches from the edge of the stud. This is a defect because it's only about 1/2 inch. Bored hole should not be in the same cross-section as a notch, and this one is, so that's definitely a structural defect. So I have another quiz for you. Remember that you can press pause at any time during the video. So if you have 2 double studs that are bored, can there be 2 of them in succession? And the answer is yes. You just can't have more than 2. So we've learned all you need to know about notching, bored holes, and cutting in solid lumber. We'll see you next time.